Hey class, today we're going to talk about absolute value functions and graphs, which is found in section 2-7, part 1 of your book. Our objective is to graph absolute value functions. All right, in example 1, we are asked to graph an absolute value function. So we're asked, what is the graph of the absolute value function y equals the absolute value of x minus 4? How is the graph different from the graph of the parent function f of x equals x? So, we've talked about parent functions so far. This is our parent absolute value function here. Okay, and so all we need to do is basically describe how this graph went from the pink to the blue. Okay, so what we're going to do first is we're going to choose some values. Now the values that we will choose will be determined based on our vertex. So if we can remember, f of x, or excuse me, y equals the absolute value of x minus 4 has only shifted our graph down 4. So since it's only shifted down 4, then the vertex is at 0, negative 4, meaning the x value is 0. So when we graph, or when we choose ordered pairs to create our graph, we want to choose x values that surround 0. So the x values that surround 0 would be, for example, -2, -1, 0, 1, and 2. So we want to choose values that surround 0. And again, we're going to put our function in the middle and then create our y value. So this would be the absolute value of -2 minus 4. That's really positive 2. So 2 minus 4 is now -2. The absolute value of -1 minus 4, that's really 1. So 1 minus 4 is -3. And the absolute value of 0 minus 4, that's really going to give us -4. Now, because this is our vertex, we should notice that everything will just start to reflect about that vertex point. So here we go. I should have the absolute value of 1 minus 4. That should give me -3, which it does. And so without doing the work, I know the other one should be -2. So when I go to graph this function, our first point will be at -2, -2, then at -1, -3, and then at 0, -4. Afterwards, it goes from 1 to -3, and then 2 to -2. So we will notice that this function looks as so. And again, it says, how is this graph different from the graph of the parent function? Translated, or you can say shifted, I don't really mind, down 4 units. Now, if you could have gotten all of this information without creating the table, that's perfectly fine, but I just want to let you know this is the background building up to example 1. So let's look at our try. In try 1, it says, what is the graph of the function y equals the absolute value of x plus 2? How is this graph different from the parent function? So again, we know that y equals absolute value of x plus 2 has basically just shifted our graph up 2 on the y-axis. So again, it's still going to surround 0 as an x value. So I'm going to choose -2, -1, 0, 1, and 2. And then y equals the absolute value of x plus 2, and then y. Okay, so that would give me the absolute value of -2 plus 2. The absolute value of -2 is 2, and 2 plus 2 is 4. Then the absolute value of -1 plus 2, that's really 1, so 1 plus 2 is 3. And then absolute value of 0 plus 2, that is 2. And again, it should reflect about it. So I'm just going to go ahead and skip past that part because it is going to be 3 and 4. You can double check me if you like. And then we're just going to go ahead and create our graph. So we have -2, +4, then -1, +3, then 0, 2, then 1, 3, and then 2, 4. Kind of missed that second one quite a bit. But again, so what you should notice is how is it different? It was translated, or you can say shifted up 2 units. And I know it's 2 because I can obviously see it from the equation. All right, so this is basically just giving us a little bit more information about absolute value or the parent absolute value function. Okay, our vertex will be centered at 0, 0. The axis of symmetry, now remember the axis of symmetry is what splits our graph in half into two symmetrical pieces. Okay, so our axis of symmetry here would be x equals 0. And then we're given the following table just to show us that when we substitute any value in, we'll get positive outcomes. All right, in example 2, it's asked, it's supposed to say which of, so that's which of, and that's the, oh my goodness. So I'm just going to cross all that out. That's supposed to say of the. So which of the following is the graph of y equals the absolute value of x plus 2 plus 3? So if we can go back and remember what we've learned thus far, we can basically figure out how this graph is shifting. So let's start with the plus 3. The plus 3 is kind of going to be the easiest part. Okay, plus 3, that is basically in the area of our y-intercept, okay? And so since it's plus 3, that should mean that it shifts up 3 units, okay? Now, the plus 2 on the inside is a little different. That's our horizontal translation, but it's going to be opposite of what we think. So if we think it's plus 2, which we would normally think it means right 2, it actually means left 2, okay? So if we look back at the origin, okay, we're trying to see which graph has gone left 2 and up 3. So left 2 would be left 2 here. I'm checking A. So left 2 and up 3 would be over here. And that's not what I have. So it's not A. I don't think it's B because we didn't go left 2. They went right 2. So it's not B. It's going to be D is our answer because we have gone left 2 and up 4. And by the way, this is our vertex. And our vertex is basically what we did, which is negative 2, 3. All right, let's look at the next one. It says, what's the graph of the function y equals the absolute value of x minus 2 plus 1? Okay, so really, since we know that the absolute value of x, the number negative 2 and the number positive 1 will tell us how it's going to shift left and right. So at least we can determine our vertex. So let's start there. All right, so this 1, remember, is telling us to go up 1. And the negative 2 is actually telling us to go right 2. It's the opposite of what we think. So we're going to go right 2 and up 1. So our vertex is actually going to be centered here at 2, 1. Now after that, to be able to create the actual absolute value, you kind of want a slope. And I'm going to say slope with air quotes, okay? There is technically no slope here. We don't really have a slope of an absolute value, but the number that generally comes in front of the absolute value symbols will help you determine how the right arm of the absolute value or the right side of the V will move. So in front of the absolute value symbol here is like a 1. So if I want to think about it as slope, it'd be 1 over 1. So to create the right arm, I'm going to go up 1 over 1 and then up 1 over 1. It'll be the exact same on the opposite side because remember it is it's going to be reflected right on the other side, or it's, symmetric on the other side. So up 1, left 1, now up 1 and left 1. So this graph here is our function. Lastly, in example 3, we are trying to graph vertical stretch and compression. So again, that ties in very well to what we just did. Okay, so we have y equals 1/2 times the absolute value of x. Okay, so we know once again that we should graph starting at the origin. Why are we starting at the origin? Because there is no number that comes after the absolute value symbol, and there's no number on the inside with the x. So that's telling us that the vertex is 0, 0. And then from there, the number in half is basically telling us kind of like the slope of our right arm. So it's telling us up 1 over 2, up 1 over 2. Now I need to do the opposite on the other side. So left 1 over 2, left 1 over 2. Oops, I missed it by a lot, sorry. But that should be our line. We're going to try these last two, and again, they're pretty simple. Again, these are both going to start at the origin. And again, they're starting at the origin because we don't have any number that comes right after the absolute value symbol as a y-intercept, and we don't have another number inside the absolute value symbols with the x. All right, so again, they're starting at the origin. I'll do this one in pink. Its slope is like a 2 over 1, so we're going to go up 2 over 1, up 2 over 1, and same thing on the other side, up 2, left 1, up 2, left 1. So this graph looks like this. Okay, the other one, again, we're going to start at the origin, but this one is saying down 2 to the right 3. So we're going to go down 2 to the right 3. I should go down 2 again and to the right 3. So 1, 2, 3. So down 2 to the right 3. We're going to do the same thing on the other side. So down 2 to the right 3. I need to create some more over here. So down 2 to the right 3. And that is that function there. Okay, so we're done, guys. If you have any questions or you need to come in for tutoring, come see me.